Okay, we're back with Unit 3, Lesson 10, Projectile Motion. You should have watched video 1 already. Now this is video 2. We're starting with example 5. Some fireworks are fired into the air from the ground at an initial speed of 80 feet per second. H is height and T is time, and they give us an equation. We got to find the domain of the function. So we want to know the T values from left to right. So what does that mean? We're going to make H 0 so we can solve this. And we want those two answers. So we're going to replace 0 on the left-hand side. Why do we do that? Because to find the domain, remember, we want the two places it crosses the x-axis, which are the solutions. To find the solutions, you replace your y value, or in this case, our h value is 0. And then we're going to solve. Now this is a binomial, so factoring is usually my best bet. Both of these numbers are divisible by -16. So I can take a -16 out and a t out from both of those terms. -16 t squared divided by -16 is going to have a t left over. Positive 80 divided by a -16, t is a -5, and the t's divided by t is 1, so there are no t terms left in our factor. Now this is factored. We now can create our table to solve each of our factors. So I'm going to set my factors equal to 0, and now I'm going to solve. Divide both sides by -16, t is still 0. Move that 5 over, and t is 5. Excuse me. So our range, the values of our domain run from when time starts at 0 all the way to 5 seconds. So this is our domain. Let's write it down. In the notation, 0 is less than or equal to t, which is less than or equal to 5. This is our domain. All right, moving on to our next one. The Apollo's chariot, a roller coaster at Busch Gardens, moves at 101 feet per second. H is the height and T is the time, and here is our equation. Now, what's the question? What is the maximum height reached by this vertex, or by this ride? So the maximum height, remember, this is the vertex, and we're looking for the y. The maximum height is the y value of the vertex. To be able to find that, I've got to find the x value first. In this case, be careful, it is x comma y, but it is t comma h. So the maximum value is the h part. We got to solve for t first. So this is a two-stepper. To solve for t, we're going to have to replace the left-hand side with 0 to find out where it crosses that x-axis. No, we don't want to solve it. We want to find the vertex's x. Sorry, I was going to take us in a wrong direction. Find the vertex's x. All we have to do is the axis of symmetry formula. So negative b, -101, divided by 2 times -16. When I calculate that, I get 3.15625. I'm not going to round it just yet. We will round in the end if we need to. Okay, so this is the x's of our vertex. This is our t. We found the x. Now we have to plug it in to find the y, right? This is our t, which is our x. So if our time is 3.15625, we're now going to plug that into our equation to find our y value, or our h, our height. Our height is going to be -16 times 3.15625 squared plus 101 times 3.15625 plus 10. You'll be tempted to want to round it, but the more you round in the middle of the problem, the more chance that you're going to make a mistake, and you'll get the wrong answer. When I calculate all this, I should get 169.391, and this is my max height. 169.391, and what was the height of the ride in feet? So in feet. Okay. 7, Eva is jumping on a trampoline. Her height, h, and t is time, can be modeled by this equation. So we're given an equation. Would Eva reach a height of 14 feet? Okay, so we want to know basically what is the max height. We want to know what is the max height, because if the max height is below 14 feet, the answer will be no. If the max height is above 14 feet, the answer will be yes, because it's just asking, can she jump up to 14 feet? So, to be able to find the max height, this is just like the previous problem. I have to find the axis of symmetry. So, x equals negative b, so negative 20 over 2 times a. Negative 20 over 2 times a is 0.625. That's your x value or your t value. Now we're going to plug that in to find our maximum height into our equation. So to find our height, h equals negative 16 times 0.625 squared plus 20 times 0.625 plus 6. You calculate that. The height she gets when you calculate that is 12.125. That's our max height. So the answer is, would she reach 14 feet? The answer is no, because she can only reach 12.25 feet. All right, a diver is standing on a platform 25 feet above the pool. He jumps from the platform at an initial velocity of 10 feet per second. We're going to use this formula, where h is height and t is seconds, and v is the starting upward velocity. We have an extra variable, and s is the starting point. To write is his starting point. To write an equation to model the dive. I don't like the way that's worded. Oh, okay, I understand what's happening. So sorry. They didn't fill out the full formula. They tell us some of the information. The diver is standing on a platform 25 feet above the pool. The 25 feet above the pool is his starting point. So that's the first thing we need. S is 25. The second thing is V is the starting upward velocity. The starting upward velocity. He jumps from the pool at a starting initial velocity of 10 feet per second. So that means V is 10. So all we have to do is read the problem and make sense of what information was not given to us. They tell us what S is and they tell us what V is in that original problem. So now we just have to substitute them in. So I have H of T equals negative 16t squared plus 10t plus 25. They just want you to fill in the equation. That's the first step. Model our equation. Now it says find the diver's height. So what is h when t is 2? So here we have our equation. Let's move it over so I have a space to do the math. So what is h when t is 2? So we're going to take the equation we just wrote, and we're going to substitute 2 in the place of t. So left side's a label, right side is the side we're calculating. So this will be our h, and when we calculate this, negative 16, 2 squared, plus 10 times 2 plus 25, that turns into negative 19. Now, we talked about we can't have a height of negative, but this is a diver. So we actually go underneath the 0 point. So if we were on the ground, this wouldn't make sense. But because we actually dive under the surface of the water, we can have a negative height because I'm diving, if you think about it, here's my water, I'm diving down below the surface of the water. This is when h is 0, and I'm going down below. So we're down here at a negative value. So our height is a negative 19 feet. This is our equation that we wrote. Erase. H of t equals negative 16t squared plus 10t plus 25. So the only time we can have a negative is when the negative makes sense, when you can actually go below where the 0 place is. All right, number 9, an astronaut on the moon throws a baseball upward with an initial velocity of 10 meters per second, letting go of the baseball 2 meters above the ground. The equation for the baseball's path is here. This is the equation for the moon. The moon is here. Now, we do the experiment on Earth. The same experiment is done, but the equation for the pathway the baseball takes on Earth, I've highlighted in yellow. Now the question is saying how much longer, so what is time when the ball, how much longer would the ball stay in the air on the moon compared to the Earth? So the first thing is I need to find the moon's time and the Earth's time. And it says how long it stays in the air. So again, let's think about what this picture looks like. I'm tossing a ball up into the air. Here's time ticking along on this line. We start up in the air and then we land back down in the air. So this is the 2 places we cross the x-axis. That's our solutions. So we have to make h of t 0. So we're going to replace in our equation negative 0.8t squared plus 10t plus 2 equals 0. And now we're going to use the quadratic formula to solve this. Okay, so x equals negative b plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. When you calculate that, you're going to get the 2 answers. Remember on a previous problem, I'm going to get the 2 answers. I'm not going to have a negative amount of time. So I'm going to throw out the negative time, and I'm only going to have the positive time. So the ball was in the air at 12.7 seconds on the moon. Now we're going to calculate it at Earth. We're going to do the same thing. We have a different equation. We're going to make 0 equal to negative 4.9t squared plus 10t plus 2. We're now going to solve. Our a is the only value that's different because in our experiment we had the same height and the same velocity. All right, we're going to plug this into our quadratic. Negative 10 plus or minus the square root of 10 squared minus 4 times a times c all over 2 times a. Again, we're going to get 2 answers, but the negative one is not the valid answer. It's only the positive one. So we have our 2 times. The ball was in the air for 12.7 seconds on the moon, and it was in the air for 2.22 seconds on the Earth. Now, final question, how much longer would the ball stay in the air on the moon compared to the Earth? So they want you to compare the 2. They want you to take the moon's value and they want you to subtract the Earth's value. When you do that, you get the amount of seconds left over. So we are in the air almost 10 and a half seconds longer on the moon than we are on the Earth. All right, that's it for video number 2. Join us for video number 3 for quadratic regression.